Hello, you're welcome to live class at Master Tima class. And here we want to look at questions on set problem. And we are checking at the WAEC past question, West Africa Examination Council past question. That is the solving question on set problem. Let's look at the year 2009. So we're picking the exam question one after the other. And we're solving. Okay. In the theory of 2009, we have question 4A. It said out of 30 candidates applying for a post, out of 30 candidates applying for a post, we have 17 half degree, 17 half degrees, 17 half degrees, 15 diplomas, 15 diplomas, and 14 neither degree nor diploma, and 4 neither degree nor diploma. How many of them have both? How many of them have both? So this is application question on sets. You can make use of Venn diagram here. So the 30 candidates here is the universal set. So solution here, we can make use of Venn diagram and we draw the universal sets. We have this as universal sets, and we have 30 candidates altogether here. We are talking about two problems here, so we are going to have two circles. We have people with degrees and people with diplomas. So that means we have two circles that will enter each other. And here we can say degrees, let degrees be D, and diploma can use degrees. We have 17 of them have degrees, so we can put it inside directly. And diploma, we can use P, any letter we want, and 15 of them have diploma. All right, now the question says 4 have neither degree nor diploma. So 4 will be outside these two circles, so 4 will be somewhere here. They are part of the candidates, but they don't have either degree or diploma. So now the question say how many of them have both. It means where these two circles intersect. So let people that have both be X. So that's the area we are finding. Then we can now continue. This region means diploma only. So it means degree only. This region means degree only rather. It means diploma will not be part. So if everything in degree is 17, so degree only will now be 17. It will be 17 minus X. So we looked at that in our previous live class. Also, for diploma here, everything is 15, and this will now be 15 minus x. So to get x now, we need to add these regions and the one here together. We have 4 now, 1, 2, 3, 4. Add it together, that will be equals to 30. So we have 17 minus x plus 15 minus x then plus 4. That should be equals to 30 here. So we solve for x here. We have minus x plus x. This cancel each other. So 17 plus 15 that gives us 32. 32 plus 4. That's 36. We have 36 minus x equals to 30. So that here, bring 30 here, take minus a there. So we have 36 minus 30 equals to x. And here, 36 minus 30, that's 6 equals to x. That means x equals to 6. So people that have both diploma and degree are therefore 6. So that's one application question, which is a past why question here. Okay, so now we look at another year. Also on set, you are solving problem on set in this class. So thank you for connecting and stay tuned to the end of the class. Also share this video, give a thumbs up and put your comments. Thank you. Now let's look at this particular question. Look at this question. So WAEC 2010. WAEC 2010. And this is number 14 or 15. Number 15 of the objective. It said given that set t is equals to x such that minus 2 less than x less than equals to 9, where x is an integer, where x is an integer, what is number of t? What is nt? This nt written here is also same thing as cardinality of set t. So we are being asked that what is the cardinality of set t? All right. Okay. Excuse me. So now we solve this particular problem or we say t. All right. I'm coming, please. Okay. Now, first list the element in that set t. The way this set is written here is in form of a set builder notation. It's described this way as t equals to set x such that minus 2 less than x less than or equals to 9. Now we are going to understand this better when we use our number line. When we are being taught number line, we have positive on the right, negative on the left, and always 0 will be at the center here. So somewhere, because the negative is not that much, so we have 0, -1, -2 here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we check this particular element here, it's starting from -2, less than. Now, strictly less than is different from less than or equals to when we are being taught inequality. So when it is strictly less than, that number will not be part. If it is less than or equals to, it's going to be part. It's going to be like this. But if it's zero less than, it's going to be open. So now, it means -2 is not part now. So we are going to start counting within the range of -2 to 9. That's what we are counting. But here, -2 is not part. Then we move to 9, but 9 is part. So the elements of C now, we now start from -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is 9 part? Because it has less than or equals to. So T now has this element which is equals to -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the cardinality of set T is now same thing as that's NT now. NT, which is cardinality of set T, is same thing as the number of elements in set T. So we count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, that's the cardinality of that particular T. All right. So that's one way of asking this question. Is a wide pass question. Let's look at another one. So we pick another year from here. When we look at the same year, 2010, the theory part. On the theory part, we also have a particular, we also have set question from the theory part. Question number 1 is also on set in the theory. So now let's check that particular question. The question says set A we have A equals to 2, 4, 6, 8. And we have set B equals to 2, 3, 9. Then we have C that is given as X, set X such that 3 less than or equals to X less than 9. Okay. Now the question says we should find the first one here. Said find one A intersection B, A intersection B intersection C. And the second one we have to find A union B, then or intersection B union C. So this is the question given, and it said these sets, they are subsets of the universe set. So we are given a universe set. Actually, this question one is B complement C complement. Okay. So and we have the universe set. The universe set is given from 2 to 9. So 2, 3, 4, 5, 6, 7, 8, then 9. So that's the universe set we have. Then, okay, let's look at the solution here. We consider the sets and the universe set. We can just see the universe set first. The universe set given, that's 2, 3, 4, 5, 6, 7, 8, 9. And we have set A, that's stated as 2, 4, 6, 8. So that's even numbers. 2, 4, 6, 8. And set B, that also is stated as 2, 3, 7, 9. Then set C is not given directly, it's described with a set builder less than equals to x, less than equals to 9. So 3 will be part. That's 3, 4, 5, 6, 7, 8. 9 is not there because it's strictly less than 9. Okay? Now, most questions that say we should find A intersection B complement intersection C complement. To deal with this question, we have A intersection B complement intersection C complement. We need to find first B complement, C complement, and then find their intersection. So find A complement, B complement, C complement, find their intersection. So what is B complement from here? B complement elements in universe sets but are not in B. So 2 is in B, 3 is in B, but 4 is not in B. Also 5, 6, 8. So this is B complement. What about C complement? Elements in universe set but are not in C. So we have 2, 3, 4, 5, 6, 7, 8. 2 and 9. That's C complement. Okay. 2 and 9. C complement. So B complement intersection C complement. What is common between these two is an empty set. And therefore, also A intersection this B complement intersection C complement. So since this is empty sets, intersection of A with this also will be empty set. Okay. Now to the second question we have, find A union B intersection B union C. So we can first find the brackets. What is A union B? What is common between A and B? Sorry, the combination of A and B. Combine A and B together. So A union B, we have 2, 3, 4, 6, 7, 8, 9. So when we combine A and B, this is what we have. Also, B union C, combine B and C. So we have 2, 3, 4, 5, 6, 7, 8, 9. So now We can now find A union B intersection B union C. So this will now be the intersection. What is common between these two? So we have 2, 3, 4, 6, 7, 8, 9. So, and that is all about that particular question. So you are watching us live here at Master T Math Class. Do well to give a thumbs up and share this video. Okay, now let's look at another first question here. In 2011 year, and when we check the objective, we have okay, then we have a Venn diagram here. You have a Venn diagram in question number 44. So let's consider that actually the Venn diagram. You are given this particular diagram and the three intersecting circles. We have S here 16. That's the Venn diagram shows the number of students in class who like reading R. So reading R here is given as 16 of them. Reading, swimming also 16. And what is the third one? Dancing. We have dancing 17. And we have 6 here, 3 here, 2 here, 3 here, 7 here, 4 here. Now we need to understand this region for us to be able to answer questions. Now say the question say how many students like dancing and swimming? How many students like dancing and swimming? So I think the answer here should be direct. How many students like dancing and swimming? So we need to recognize where is the region for dancing and swimming. Okay, the diagram is correct. How many students like dancing and swimming? Okay, this three is here. This three is here. So dancing and swimming is when you look at the circle, this is circle for dancing, and this is circle for this is circle for dancing, this is circle for swimming. So dancing and swimming intersects this region. So once we get this place, just add it to 2. That is dancing and swimming. So what is X? We can get X since everything in swimming is 16. So add it together, subtract from 16. 2 plus 3, 5. 5 plus 6, 11. So 16 minus 11, that's X, and that's 5. So if this is 5, if X equals to 5, easily now. So dancing and swimming is now equals to 2 plus 5, which is equals to 7. So it's as easy as that. When we answer problem in sets, we understand what we are talking about. So be able to solve question easily. Right. Let's look at another question. Let's move to the year 2012. 2012, when you look at the y equals question, discover here we don't think we have any in the OBG. So the OBJ question here for 2012. Try to check. Now let's look at the theory part of that. We have a particular question here, interesting one actually. So part B of the theory, number 6B. There a number of tourists were interviewed. A number of tourists were interviewed. Look at, let's read the question and solve directly. That we are going to save some time. We have a number of tourists were interviewed on their means of travel. Two-thirds said that they travel by road. So we have travel by road. We can, this two-thirds. Now, the certain number of travelers, we don't know the travelers. So two-thirds of the travelers, let X be the total traveler. That's two-thirds of X. So that's one thing about mathematics. If you don't know something or no, you represent it with a letter. You say a number of tourists. Normally, they're supposed to give us the total number of tourists, but we are not given. So let the number of tourists be X. So a number of tourists were interviewed on their choice of means of travel. Two-thirds said they travel by road. That means two-thirds of the total. So that's why road two-thirds. Then 13/30 by here. So here, let that one be here. Road R. Here, 13/30 of the traveler. And 4/15 by both here and road. So both road intersection here, both road and here, we have 4/15. 4/15x. You see something now? If 20 tourists do not travel by either air or road, so which means R complement intersection air complement neither. So that's 20. 20. They gave us that certain number. That's a fraction of the total. So that one is certain. The number is certain. That doesn't travel by him. Now, represent the information on the Venn diagram. That's the first question. How many tourists were interviewed? That's the number of tourists. How many travel by air only? Now, let's interpret this question in Venn diagram. We have two set problem here. You can draw the Venn diagram, and the universe set here is not known. So that's why we say X. We have two problems. That's two circles. The first is by road. Road is two-thirds of the total X. And here is 13/30 X. And both, we have 4/15 X. And those that not travel by any means, we have 20. So now, what are we doing now? We want to find this region. This region is road only. How do we get road only? Easy. Everything here is two-thirds. So subtract this. So that will be 2 over 3x minus 4 over 15x. So what's the fraction here now? So when we solve that fraction, that gives us 2 over 3x minus 4x over 15. SCM 15. Try to bring it together. So 3 going 15, 5 times 2x, 10x minus 15, 15, 1 times 4x, 4x, 10x minus 4x, that's 6x over 15. 3 goes in 6, that's 2, that's 2x over 3 goes in 15, 5, that's 2x over 5. So everything here is simply 2x over 5. So note this, that's root only. And also by here only, it's going to be everything here, that's 13 over 30, x minus 4 over 15x. So simplify this as well. So we have 13 over 30 x minus 4x over 15. Also bring it together. And we have SCM here 30, 13 31, 1 times 13x, 13x minus 15 32, 2 times 4x, 8x. Subtract 13x minus 8x, that gives us 5x over 30. And 5 goes here, 1, that's x over 6. That's x over 6. It means here, those people that travel by here alone, that's x over 6. I believe we are following. So this region now, which are 4, this is 2x over 5, 4x over 15, x over 6, and 20. So add these together to get an equation to get the value of x. So what we have here is now going to be, so we are going to have 2x over 5 plus 4x over 15 plus x over 6 plus 20 now equals to x. So just solve this fraction. Clear the fraction. When we find the SCM here, this is to clear the fraction. And the SCM here is what? So I think that should be 30. 30 should be the SCM here. We multiply through by 30. It depends on how you want it. So multiply this through by 30. 30 times 2x over 5. 5 goes in 36. 6 times 2x, that's 12x. Plus 30 times 4x over 15. 15 goes in 32. 2 times 4x, that's 8x. Plus 30 times x over 6. 6 goes in 35. 5 times x, 5x. Plus 20 times 30. That's 20, 30, 0, 0, 0, 6. That gives us 600. So 600 equals to x. Then we solve by okay. I hope there's not been any error. So we had, oh sorry, there's a mistake. So we multiply through by 30. We should multiply this side by 30 as well. So this 30 times x, that's 30x. Thank you. Now, by the time we solve, we have 12x plus 8x, 20x plus 5x, 25x plus 600 equals to 30x. So we can bring x to one side. This here we have 600 equals to 30x then minus 25x. This here we have 600 equals to 30x minus 25x, 5x. Divide both sides by 5. Divide this side by 5. Also divide this side by 5. 5 cancel each other here. And x here equals to 5 in 600. That's 120. So x is 120. The total number of tourists is therefore 120 tourists. Now, The second question says number of travelers which travel by air alone. Air alone, that's air only. So air only now is going to be this region. It has nothing to do with road. So which is x over 6. Air only, x over 6. So those that travel by air only now, air only is now equals to x over 6, which is 120 over 6, which is 20. 20 travelers travel by air only. So we have that as a correct question. So if you have your series with you, and cross-check that question now. Look at the video again and understand. Examiner life setting application question when it comes to Venn diagram. So I hope you enjoy this class and you learn something from it. So this channel is basically for mathematics master T math class. Don't miss out on any of our videos. As well, watch our previous live classes and subscribe. Share this video as well and give it a thumbs up. So when next we meet, we start to solve more of questions on sets. I appreciate you for connecting and see you in our next class. Bye for now.